All right, so we'll just go ahead and start right now. Last time we were looking at, we introduced SQL and databases, and we understood the reason that we want databases is because we can't always be working in flat files. Databases store things in tables. Tables have columns and rows. And then we started on our CRUD demonstration. In fact, what we did is basic CUD, where we create, update, and destroy. We inserted records into an existing table. We updated records where we got wrong, so place stuck became place stack. And then, of course, we deleted records. Let's make some observations about what we did last time, right? So that if you update or delete, right here we go, update or delete without a where clause, right? It may affect every record in the table. That's not what you want. Generally, MySQL Workbench's safe mode will save you from yourself. Will save you from this, but not always, right? You can turn it off. I'm not even going to show you how. If you want to, look it up, but then don't come crying when all of your data is gone, right? Generally, safe mode will save you from this. Later on in Java, when we connect to the database, there is no safe mode, right? So there is no undo, there is no backup or anything like that unless you made the backup, right? Some other things that we observed are if you have a parent-child table, right? Then the parent must exist before you can create any child records, right? Also, if you have a parent-child relationship, the children, right, records must be deleted before the parent record can be deleted, right? This is in a well-organized database, a well-designed database. You can have a terribly designed database where there are no checks like this, where there are no foreign keys, right? Where basically you're going back to the flat files, right? Where you have no enforcement, you have no rules. But in a well-designed database, these are the things that you want to look for. And remember, here's our schema from last time. You have a parent-child relationship if it's a one-to-many relationship, right? So a parent is the one, the child is the many, right? In a one-to-many relationship, right? And another thing to note here is that the child has the foreign key, or foreign key. So over here with the publisher in the game table, there's the parent, and there are all of its children. The child always has the reference back up to the parent. Okay, so you know whose child this is. And if we were to delete a publisher, remember that we also have a grandparent, parent-child relationship with those three tables. So if we were to delete a publisher, we would end up having to delete any availability records, delete any game records, and then we can delete that publisher if we really wanted to. We wouldn't have to do anything with the platform table because it's independent of any of these, right? If we wanted to delete a platform like delete PC games forever, right? Then we'd have to delete all of the availability records before we can delete that parent record. In some cases, you only have one parent. In other cases, you have multiple parents. And yes, you can have 3, 4, 5 parents, although really rethink that design. This is a join table. Usually join tables only join together 2 tables at once, okay? What else was there? I think that was it, right? For CUD, for create, update, and destroy. Yeah, so let's go ahead and start on the basic R, right? Retrieve. Remember CRUD is create, retrieve, update, and destroy. Those other 3, there's really only one way of doing it. But with retrieve, that is select statements, there are many, many ways of doing it. So remember, to get started, you need to use your own database, right? And so let's go ahead and select everything from game, okay? So this is just a blind select all records and all columns, right? So this is this asterisk or this star operator. That is a wildcard. You're going to get all of the columns. So if I select everything from the game table, I get everything. I get the game ID, the name, and the publisher ID here, right? And that's what's in the game table over here, right? I get all of the records 1 through 20 down here, right? And I reinstalled it so that we're from scratch here, right? So what if you don't want everything? You can limit the columns using named columns, right? Columns, there we go. So select, I don't want everything. I just want the game ID, right? Game ID, and the name, right? From game. I don't care who the publisher is. And if I do that, I'm only going to get those 2 columns. Or if you only want 1 column, then you can just get the 1 column, right? So if you only want a subset of those columns, you just have to name them instead of using the wildcard. Now, when we're working in MySQL Workbench, using the wildcard is perfectly fine. In fact, that's what you usually do. But eventually, when we move over to Java, you're not going to want using the wildcard is actually bad practice. Because what you end up doing is you end up pulling all of the data over the network, whether or not you wanted it or not, right? If you were only interested in the game ID and the name, but not the publisher ID, then don't send that publisher ID over the wire, because networking is still computing's bottleneck. It is still the slowest thing with respect to computing, right? So you can limit the columns using named columns. You can also alias columns, right? So select game ID, comma, name as game title from game, right? So this as is going to rename that column name to game title if you want something more descriptive. Now I've got game ID, and unfortunately it's kind of difficult to see, but you can see that it's game title right here. That only aliased it for the purposes of that select statement. If I describe game, it didn't change anything with respect to the game table. It is still called name there, right? It only aliased it for the results. But that can come in handy if you've got, say, multiple columns that you need to disambiguate. Eventually, we're going to pull all of this data together, and we're going to be interested in who the publisher is, what the game title is, and what the name of the platform is. We'll end up having 3 columns all with the same name. But if we use aliases, then we can rename those columns and disambiguate it so that we're not getting 3 columns with the same name, right? So you can also alias columns. So note on style before we move on here, right? The old style is to use all uppercase. Remember, select game ID from game, right? And that's because back in the 1970s, they had single monochromatic monitors, green screens. And so they needed a way to offset keywords like select and from everything else. But in actuality, I think I mentioned this on Wednesday, in actuality, it is case insensitive. So you could do something like this. Select everything from game, right? And if I do that, I get the exact same results. Never do that, right? And you should not do this, because this is the old way of doing it. A more modern convention is what I've been showing you, all lowercase, because you don't want to sit there with your finger down on the shift key every single time, right? You can also break things up. White space doesn't matter. No, white space doesn't matter, right? So for example, let me go ahead and bring that down here. I can go ahead and put that down to the next column, right? And I can put that down there or something like that. And if you want to, you can break up long lines like this, okay? If you want to, you can start using a beautifier, right? And so, I don't know, SQL beautifier. There we go. Let's bring this over here. Let's see what it would do. In fact, let me go ahead and get rid of any white space there at all. Go ahead and put it all on one line over here. What do they suggest that we should have done? So let's go ahead and move that and then put that all onto one line. And then let's beautify it. That's what they would look for, right? So a slight indentation on the column names. All the keywords are out front, no indentation. And then the names of the table, names of the columns are all indented. We don't care as long as you are following a consistent naming convention, right? So there's the suggested, right? So you can use a beautifier to get something like this. But generally, white space doesn't matter, okay? Let's see, what else did I want to say on style? That was all I wanted to say on style, I think, right? But again, we use this modern convention here because we have color screens now, right? We've had color screens for a long time, right? And so we have code markup language like this, right? In fact, if you look at the notes posted here, you're going to have slightly different colors, but that's what it looks like on GitHub, or that's what it looks on my Markdown preview, which tries to use a GitHub style, but it might look a little bit different on GitHub. Okay. All right. So back over here. Right? So that is retrieval. Right. You can reuse the wildcard, or you can use individual columns there. There are also aggregate functions. So you can start doing, this is why I left select for the last, because this is where the real power in SQL comes from. You can do data processing directly on the database. So if I want to select everything, let's say a count of everything from game, that is going to give me a count of the number of records in that table. And there are 20 records in there, because remember we started out and I said that there were 1 through 20. There are 20 records there. Now that is not a real column. That is a column that was created for the purposes of this query, of this select statement here. So this is a perfect instance in which you would want to use an alias as number of games. Right, there we go. There, number of games now is giving you 20 instead of that count star. What the hell is that? Right? If you generally SQL folks, right, what they're doing is they're generating reports for some business folks or something. And so, of course, if you're going to hand them a report that says count of star, right, they're going to say, what the hell are you talking about? Right? You're going to want to give that a descriptive name. Well, the number of games in our system is 20, right? Something like that. So aggregate functions with aliases there, right? So there are other aggregate functions. We've already seen here now count, right? There's also max, min, and AVG. So max, min, AVG is short for average. It's not AVE, it's AVG, okay? So let's go ahead and select the max. And unfortunately here, I only have one column that makes sense for this, the publish year. So let's find the oldest game, or the newest game. Let's select the max publish year from availability. Execute that. So 2011 is the most recent game that I've actually played, right? What about the oldest game? Right? Min. Execute that one. 1985, right? That's the oldest game I've ever played, at least according to this data, right? Now, what are those games? Do we know what those games are yet? No. To be able to determine what those games are, I would have to take the game table and the availability table, and I would have to join them together somehow. We'll be doing that maybe by the end of the day, certainly next week. But in any case, that information is not available in this availability table. The publish year is, but the name of the game is not, and certainly not the publisher, whoever created it. So we'll have to do that later. Now, it doesn't make much sense here, but you can take the average publish year. I suppose you could get a weighted average of my gaming career, right? Like when was I generally playing video games? It was about 25 years ago, right? All right, so average may or may not make sense. But you can actually turn it into any calculation can be performed. So suppose that I'm running SQL queries here on an Oracle database, which costs several tens of millions, up to tens of millions of dollars, because you're paying for long-term support, you're paying for the infrastructure, you're paying for the actual software, et cetera, et cetera. So if you're paying Oracle tens of millions of dollars, you can turn it into a glorified calculator. 8 times 4 minus 3 divided by 8, right? There we go. Whatever that is. Right? And now it's a calculator. Right? And it's 31.6250. Right? So you're able to use that with other select statements. For example, if you take the average, you can also multiply that by 10. Right? Right? And now it's, instead of the year 2000, it's the amount 20,000 here. Right? So you can use multiplication, subtraction, division, and the one that I didn't use here, I guess, is plus. So 3.5. There we go. And you see that it's all a fractional value. Just like, say, Python or PHP or something like that, there are only floating point types. You can force this to become an integer, maybe. Is this going to work? I don't think that this will work. No, this is bad syntax. Ignore that I just did that. Okay. And by the way, the most common error we see, select 8 from games, or a game, excuse me. What did it just select there? 28, right? Why? Because I wasn't holding down the shift key when I meant to have the asterisk there. So be careful, right? Careful. Hold down the shift key, right? But that's a really common mistake. So if you ever see 8s, you know, oh, somebody's pinky is getting tired, right? So there's, oops, nope, no, I'll stay over here and keep, I'll put these into the notes later on, right? All right, so you can also limit the results using a where clause, using where clauses and logic operators, right? So select everything from game where game ID is equal to 5. Right? Legend of Zelda, 5. Right? Now note here that it's not equals equals. I wonder if that won't even run, right? Because equals is a Java thing, right? Or a statically typed language thing. That's equality. This is not the assignment operator either, because SQL is actually a more what's called a declarative language. It's not telling you're not writing code like a for loop or something like that to say that, okay, go out to this table and if for each game, if the game ID is equal to 5, then add it to the results and then return the results. You're not writing a function to do that. You're not writing a loop to do that. You're not writing an equality operator here to do that. You're declaring that this thing is a result. Right? So it's a declarative style of programming instead. Right? It's more functional programming. Declarative is a subtype of functional programming. But in any case, you can go ahead and use any other operation that you are already familiar with from game where game ID is not equal to 5. Right? Now, if I do that, I'm going to get the 19 other games that are not The Legend of Zelda. Okay? And there are 19 here. Okay? The one with 5, it goes from 4 to 6. Again, it's kind of hard to squint, but I can't zoom in on that. I can only zoom in on my editor here. Right? You can select everything from game where game ID is greater than 5. Right? And that'll get me games 6 through 20. Right? 6 through 20 there. Greater than or equal to. Greater than or equal to. Now I am getting 5 through 20 instead. Right? So all those operators that you're familiar with. You can use compound operators. So select everything from game where game ID is equal to 5 or game ID is equal to 7 and I don't know, or game ID is, actually let's go ahead and go with greater than or equal to 17 and game ID is not equal to 15. Right, there we go. Okay. So I'm getting the game ID 5, or it's greater than or equal to 17, but it's not equal to 15. I guess that's kind of stupid, but let's go with 18 there. And then we'll end up excluding X-Wing versus TIE Fighter there. And now it's not there anymore. Right? So you can do as much as you want here, or you can even put in parentheses to disambiguate this and get it to do something else. Right? Or that might give me something else there. No, it's giving me the same thing because the logic is the same. But you can use parentheses. The keyword is or. It is not shepherd stroke there. The keyword is and. It is not the ampersand. Those are not SQL keywords. Okay. So those coming from a Python background will appreciate that they're using the proper English words for these operators. Okay. So there's compound operators. You can also do string matching. So select everything from game where title is equal to, or not title, it's name, right? Is equal to, I don't know, portal. There we go. and there, right? And execute that, right? So there we go. We've got Portal, which is game ID 13, and its publisher ID is 11. That's probably Valve, right? Right. Okay. Note here that I am using single quotes. You can use double quotes. Just be consistent about it. Right. I would generally suggest that you use single quotes because that's the usual way of doing stuff. Right. You can use either or. Right. Generally prefer single quotes, though. Right. Okay. That is string comparisons right there. So same thing there. And by the way, you can use greater than or equal to here, and then you'll get everything that is greater than or equal to Portal according to lexicographic order. So since this is capital S, that comes after capital P. Capital Z certainly comes after capital P, et cetera, et cetera, et cetera. We got Super Mario Land, Tetris, TIE Fighter, et cetera. Okay? So you can use all the same operators that we covered up here with strings. You can use partial string or matching. Right? So, for example, you can say using the string wildcard, which is the percent sign here. So select everything from game, where name equals G, and then followed by anything after that. Now, it's not going to work here. I'm going to show you why in a second, but I would expect this to come back with GTA 1, GTA 2, GTA 3, GTA 4, right? Because those games all start with a G followed by anything. That's a wild card. It will match any number of characters, right? The reason it's not working is because you have to use a different you have to use a different operator here. Instead of the equals operator, you have to use like, right? So note, you have to use like with wildcards. Right? And when I do that, I am going to get those 4 GTA games. 1, 2, 3, and 4. Right? Okay? You can put multiples in. So if you want anything that contains, say, a lowercase a, so that will follow. That will match any number of characters, as long as it's followed by a lowercase a, followed by any number of characters. Right? So this one is all games that begin with a G. Right? Right. This one is any games, all games that have a lowercase a in them. Right, in the name, that is, right? And so I'm going to get a whole lot of them. Legend of Zelda, Super Mario Land, LAND, right? Portal, Portal 2. And it is case sensitive, by the way, right? All queries are case sensitive. I'm going to put an asterisk there because we're going to come back to it, right? So if I did this, I'm going to get completely different games. The GTA's games are still there because there's a capital A in it. But Adventures of Link is why we're getting that one now, a capital A. But I'm not getting as many games as I was before. So what do I mean by this asterisk here? I'm going to fill in the blank here. If the database is set up sensibly, right? So I've said it multiple times, but anything that matters in computer science is case sensitive. File names, file paths, anything that matters should be case sensitive. Unfortunately, they didn't really think like that back in the 70s, so they thought, oh, well, it doesn't matter if it's case sensitive or not. Well, yes, it does. It should matter, right? So if the database is set up sensibly, that is, it is case sensitive, then these two queries will be completely different, right? If you have a poorly set up database that is not case sensitive by default, then these two would end up being the same, okay? How would we combine both of those, by the way? Get any game with A or A in it. So yeah, just do an or. Or name like that, and then that, the wildcard A, there we go. And now I'm getting all those games again, including GTA 1 through 4, even though it doesn't have a lowercase a in it. Okay? All right, just use compound logic like you've been doing in your programming languages up to this point. You can also match single characters using the underscore. That is this thing right here. So shift and then hyphen gives you the underscore. So select anything from game where name like, you still need to use the like here, that begins with any letter as long as it follows any two letters as long as it follows with an E in the end or something, right? And then anything after that, right? So TIE Fighter, there we go, right? So Y because capital T, lowercase I, E, and then anything following that. Now, if I didn't have that wildcard at the end, then I wouldn't get anything back because there are no names that have any two characters followed by an E followed by nothing, right? So there. Or another example would be beginning with anything and following anything. There we go. I was looking for things with the in it, but I'm going to get a lot more. Right? In fact, I only have one thing with the in it. Right? So you can do that, I guess. Now I'm only going to get Zelda 2, The Adventures of Link. Right? Undo, 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 so that you can see that you can use single characters there. That's really powerful because you can find anything that is exactly 3 characters long or something like that. Say 1, 2, 3. Right? There I'm only, oops, I didn't want the wild card there. So something that is exactly 3 characters long is that single GTA Part 1 game. Okay. All right. Let's see what else. All right. So ordering. So generally, the order of columns and rows does not matter, right? So you can rearrange columns using named columns like we did before, right? So select not everything from game, but let's go ahead and select, well actually let's select everything from game initially, right? And you'll see that the column order here is the order in which I created the table. Game ID, name, and publisher ID, which matches this picture over here. It doesn't have to be that way. You can go ahead and put the name first and then the game ID second. And now it has taken those 2 columns and it's swapped them because the order doesn't matter. Okay. Also, you can rearrange. You can order rows coming out. Right. So you can sort them basically. So select everything from game. Order by name. Right. So at the top now we have contra C, then the G's, then the K's, then the L's, all the way down at the bottom we have Z. So ascending is the default. Right? So if you don't want the default, you can go ahead and change that. Let me go ahead and grab this and use desk for descending. Right? So after order by name, I'm going to say descending after that. DESC. I think you can do, no, you can't do descending, the word. It's desk, right? And now Zelda is at the top and Contra is at the bottom. Right? Okay. You can use a combination of columns as well. So let's go ahead and select everything from game, order by their publisher ID. That way I'm going to get all of the publishers all grouped together here. And this is going to come in important later on when we use a data projection. When we have all of the publishers with ID 1, ID 5 are all together, 6, all the way up to 13 there. But now what I want to do is I want to order any game by that publisher as well. So order by publisher ID, let's say ascending. Right? So ASC is if you want to force it to become ascending. Then by, but you don't use then by, right? You just give it a name here. Then by name, descending. Hopefully that's enough. Nope. Comma. There we go. I think. Yeah, there we go. There, just a comma. So take a look at what the result is now. All the publishers with ID 1 come first, but within that group, we have ordered them descending. So X-Wing versus TIE Fighter is at the top and Lego Star Wars is at the bottom. Here's Nintendo, right? 5 is Nintendo. There we go. Legend of Zelda is at the bottom, but Zelda, Z, is at the top. So all you need to do is specify 2 columns here and then a comma, right? This is very, very spreadsheet-like. If you've ever done a lot of work in Excel, you can go up and sort, and then you can, it pops up a dialog, sort by which column, ascending or descending. Then you can add a button and it says then by what column, ascending, descending. Right? And why is that? Well, because they designed spreadsheets after relational database systems, but they are not relational databases. If you're looking for an Office suite equivalent of a relational database, that's going to be Microsoft Access, not a spreadsheet. Okay, all right. Spreadsheets are completely different. They don't have a data model. Right? All right, so there's the ordering of everything. Any questions so far? There's another nice keyword. You can use the distinct keyword to get unique results. So for example, select distinct publisher ID from game. Right? Because if I didn't put that distinct there, let me go ahead and remove it. I'm going to get duplicates. All the 1s, the 5s, and the 6s, and the 10s, et cetera, et cetera. I'm going to get as many games as they've published. But by putting distinct in front of there, then you are only going to get unique values. 1 appears once, 5 appears once, 6 appears once, 8 appears once, etc. Right? Let's see. That's the distinct keyword. You can use the in clause to avoid complex disjunctions. When I say disjunction, I mean ORs, right? So ORs. Right. A disjunction is just an OR, right? So select everything from game where game ID is equal to 3, or game ID is equal to 5, or game ID is equal to 7. Right? The first few primes there, I guess I missed 2 there, but that's all right, right? Or, disjunction, disjunction, disjunction. It gives you all 3 of those games. You could better and more compactly write this if you select everything from game where game ID is in, and then you can make a set out of this. 3, 5, 7, right? And you'll get the exact same results, but with less typing. Now, the reason that you would want to do that is because you can use it in use a nested query. This doesn't have to be a fixed set. It can be another query. Select publisher ID from game where name is like G. Let's get all those GTA games, right? Do they have distinct publishers or not, right? Execute that. Oh, oops, sorry. Oh, what am I doing? Right there. So game ID, oh, no, game ID, I should say publisher ID. Actually, that's a good mistake to have, game ID, right? So why did it give me Super Mario Brothers when I was looking for all those GTA games and their publisher? It's because I was selecting a publisher ID, but I was matching it with the game ID. So Valve, publisher ID 5, ends up being my game ID over here. You've got to compare apples to apples, oranges to oranges. You can't compare a game to a publisher here. So publisher ID. And then I will get all of those games there by Valve, which apparently is 6. Okay? But that's why you would want to use an in clause. Okay? So as an aside here, in fact, everything in a relational database, everything in a relational database works on set theory. So most of you are taking, say, CSCE 235 right now. You probably started out with logic, right, and implications and antecedents and stuff like that. Are you on to set theory yet?
Just today.
Just today? Okay. So then I'll reinforce that. Right? If I have a set A of values, say, and I'm going into LaTeX mode here. When you see this on, it will render correctly on GitHub, but if you download like the raw markdown, you'll be seeing raw LaTeX as well. So if I say A, B, and C, there we go, A, B, and C. A is a set containing 3 elements. Its cardinality is 3. Right? And you can use other notation like this. For example, is A in A? Right? So have you seen that before? Or maybe, did you start on that today? All right, good. This is read as the element A is in the set A. Right? Is in the set A. Now, that's why we use that keyword. Where the game ID is in, and then this is a set over here. However, in mathematics, we use the curly brackets. Over here in SQL, we use the parentheses. Right? So a distinction is that brackets brackets are used in set theory, math, the math versions of those, and parentheses are used in SQL, right? So understand, though, that basically it's the same idea. All of these things are set theory, right? Now, you probably definitely haven't got to it yet, but actually, no, let's start out with this. What if I said that A is equal to A, B, and C, and then B, another set, is equal to 1 and 2, right? So different values in those two sets. What is A cross A? B, excuse me. Right. Okay, cross is not allowed times, I think. There we go. Okay. So have you talked about that yet? So that's all right. I'll go ahead and give it to you. It's all pairs, A and B, such that A is an A and B and, so here's your B, wedge. It's been so long since I've done logic in LaTeX here. And B in B. There we go. All right. So do you remember what that was from? That is from the first couple of weeks of 235. It's just the and, right? What's the or? It's the V, right? So A is in A and B is in B. So in this case, what would A cross B be? Right? It's going to be a bunch of pairs, right? Oops, sorry. Actually, those coming from a Python background are really going to appreciate this because you call those tuples, right? And a two tuple is exactly what we're doing here, right? It's going to be A matched with 1. It's going to be A matched with 2. It's going to be B matched with 1. It's going to be B matched with 2. B matched with 2. And it's going to be C matched with 1 and C matched with 2. There we go. What is this called? Have you talked about this yet in 235? No? This is called the Cartesian product or cross product. You've been using it since grade school. You just didn't realize it. Right? What if I said this? Math BBR. First of all, what is that thing? That's the real numbers. What if I took the Cartesian product of it with the real numbers? That. What am I talking about now? That's it's the real numbers on what? It's the Cartesian plane. Plane. There we go. That's not right either. It's plane. There we go. The Cartesian plane. In other words, the x-axis and the y-axis. What is a point in that thing, right? That's x comma y in, right? That set, that cross product, right? Cross products are going to be super important when we come back on Monday because we're going to be joining tables together. But we're not there yet. Instead, what I want to do is I want to do data projections, and that's what we'll end on here. Right? So data projections, right? Data projections. Right? I mentioned all that because, of course, it has applications in geometry and everything like that. If you were to take a three-dimensional object, say a 3D cube, and project it down onto the plane, that looks right, then what do you get? You get a 2D what? Square, right? Or trapezoid, depends on the angle that you're projecting it down on. But it looks something like this, right? So if you've got a three-dimensional cube here, x, y, and z, and then you project it down on a two-dimensional plane, you are getting rid of a coordinate. You're going from x, y, z down to just x, y. Right? And that's the idea of a data projection. You are projecting 3 columns down to 2, or something like that. You can project n columns down to n minus 1 columns or less. Right? Now, why would you want to do that? Let's look at an example before we actually look at the syntax. I've got a whole bunch of books here in my collection. Right? And I've also got an author. And then each one of these, this is in a library or something, we have 10 copies of The Naked and the Dead by Norman Mailer. We have 4 copies of Dirk Gently's Holistic Detective Agency. We've got 3 copies of Norman Mailer's Barbary Shore. What I want to know is how many copies of Norman Mailer books do we have? Right? So if I went through this manually, I'd say, okay, well, there's Norman Mailer, so 10 plus 3, that's 13. What about Douglas Adams? There are 3 books there, but they're copies of 4, 2, and 1 respectively, so there'd end up being 7 copies altogether. There's only one Orson Scott Card book with 7 copies, so we would want to say Orson Scott Card has 7 books in our collection. Right? What I want to do is I want to group them first of all. I'm going to group them by the author so that all the Norman Mailer books are together. Then I'm going to group them so that all the Douglas Adams books are together, just like we did with order by, right? But this is going to be group by, because we're actually going to do a projection after this. So I didn't change the data here. We still have 1, 2, 3, 4, 5, 6 records. I still have 1, 2, 3, 4, 5, 6 records here, and they all have the same data still. But now what I'm going to do is I'm going to project those 3 dimensions down onto 2 dimensions so I can produce more data. What I'm going to do is I'm going to project the author and the sum of these number of copies down onto 2 columns, right? 2 dimensions. So that Norman Mailer here, when you sum those up, you end up getting 10 plus 3. You end up getting, for Douglas Adams there, you end up getting 4 plus 2 plus 1 is 7. And then Orson Scott Card is 7. Okay? Let's do the same thing over here for games, right? So you can project data by using the group by clause. Let's do that first, and then we'll understand the data aggregation out of it. So let's go ahead and select everything from game, group by publisher ID. Right? So in this case, we'll end up grouping by all the publishers. Right? Kind of like what we did before, where we ordered by all the publishers, but we're going to get different results now. Right? You'll note here that since I grouped them, it's already been projected down here. All of those 1s are now just a single 1. All of those 5s are now a single 5. Now that doesn't give me what I want. I want to know how many games each publisher did, right? So this doesn't really have an interpretation yet, but you can use you need to use an aggregate function to make sense of it. Right? So select not this, but select count of everything from game, group by. Here it would have been like a sum instead. You're summing up the number of copies, so that 10 plus 3. Here I am simply just counting them because I want to know how many games there are. I don't have the concept that I have 5 copies of The Legend of Zelda sitting at home or something, right? So we're going to count from game, group by publisher ID, right? And then we also want the publisher ID. Publisher ID. There we go. So publisher ID 1 had 3 games. Is that correct? Do you remember it? Let's just select everything again, make sure. Select everything from game. Right? And then I'll order them by their publisher ID over here. 1, 2, 3. Right? Whoever that was, it's LucasArts. Lego Star Wars, TIE Fighter, and X-Wing versus TIE Fighter. Was Lego Star Wars by LucasArts? I guess there'd be 2 publishers there, right? Because LucasArts doesn't exist anymore. What about the publisher ID 5? 1, 2, 3, 4, 5, right? Let's go back to our aggregate function here. Publisher ID 5 also has 5 games. And by the way, this is where your aliases really come in handy. Let me go ahead and move this over here to publisher ID first, and then count. I'm going to rename that as number of games. There. Publisher ID 1 has published 3 games. Publisher ID 5 has published 5 games. Publisher ID 13 here, they've only published 1 game. Okay? Now a couple of things here. First of all, does this give me enough information to tell me who these publishers are? Not yet. We need to be able to go back over here to the publisher table after we've done this. Second, what about all the publishers with no games? Are they appearing here? Nope. Because otherwise they would end up appearing as zeros. Those are 2 problems that we're going to have to solve by doing another thing, which is called a join. And for that, I'm going to motivate the math before we go. Actually, we already did. I should have held off. This is a join, right? The Cartesian product, also sometimes called a cross product, or in SQL, it's called a join, right? Or a cross join, right? And basically what you're doing is you're taking elements in table A, and then you're combining them, you're joining them together with elements in table B in order to get this cross product right here. But then you want to filter them, because I don't necessarily want every single publisher here matched with every single game. It wouldn't make sense for Namco to have published Legend of Zelda when Nintendo did, or vice versa, right? So what I want to do is I want to join these two tables back together, but I only want to join them in a manner that makes sense if their publisher IDs match, right? Because that game was published by that publisher over there. It wasn't that the Legend of Zelda was published by every single publisher over here, which is what you get with these cross join, right? But we'll look at that on Monday. In fact, we'll start out with a cross join to see how disastrous it can be, right? Let me show you really quickly here. How many games are in there? Count, star. We've got 20 games. So if I were to do something like this cross join, right, where 20 games are joined with 20 other games, how many records would you end up with? 20 times 20 is 400, right? So join game. There we go. Left join? Nope. What's that? Not unique. Okay. G2. There we go. Now it'll let me do that. 400. So if I just blindly join records, I'm going to have n squared of them, right? If there's n over here and there's n over here, then you end up having n squared. 20 times 20 is going to give you 400. This is a super small database. I've only got 20 records in that table. A real database has millions of records. So what is 1 million cross-joined with 1 million? What do we call them? Trillions. Right? A big number, right? And what if they had tens of millions of records or a billion records in the table, right? You could support up to 2.147 billion records in a table. 2 billion times 2 billion, that's going to be what do we call them? I have no idea. Quintillion, quadrillion, something like that, right? And do you think that that's coming out of your database anytime soon? Nope. You're sitting there twiddling your thumbs because it's going to take 20 years for that to compute, right? So be careful. You don't want these blind joins. You certainly don't want an infinite join like the Cartesian plane there, right? But we'll pick it up there on Monday because remember Friday there is no class nor live stream because of a writing seminar for me, right? All right, see you on Monday.